Okay, so in this lesson we're going to be looking at the things and the steps that are necessary for solving simple equations. Now, to enter into this we need to have some basic vocabulary down, which hopefully you have, but just as a quick review. The first is an expression. Now, by definition, an expression is a mathematical statement involving numbers and or variables. Expressions are meant to be simplified in their forms, but cannot be solved. One thing that I hear quite often amongst people who are studying or learning mathematics, even those that are well versed in it, is that when they see an expression such as 3 plus 5, they say they want to solve this. Well, you can't solve it, and we'll talk about that in a minute, but you can simplify this. This is simply 8. Another one would be 2m plus 4 minus m. If we wanted to simplify this, we would do what's called combining like terms. In other words, we look for items that have the same variables or no variable at all. In this case, we have a positive 2m and a negative 1m. So 2m minus 1m is simply 1m plus 4. Since the 4 does not have a variable, it cannot be combined with the others, and this is the simplified form of the expression. We cannot solve because in order to solve we need our next vocabulary term, and that is the equation. Now, an equation is a mathematical statement that places two expressions equal to one another. Equations can be solved. An example of an all-numeric equation would be if I took 3 plus 5, as I had before, and the expression 6 plus 2. Now 3 plus 5 is 8, 6 plus 2 is 8, so these two are equal to one another. So by taking the expressions and stating that they are equal, we can come up with an equation. Now what we're going to be working on is finding unknown values in our equations, and that's going to be the focus of our work today. Now, once we find that unknown value, we have our next vocabulary term, and that is solution. And a solution, quite simply, is a value that makes the equation true for a given variable. The solution can be a number or another expression. And what I mean by that second part is sometimes when we're solving things, we have more than one variable in there, so we're going to end up with expressions for a solution. The variable x might equal something in terms of y or p or some other variable. And we see this when we're working with formulas, especially in geometry. But we will get to that further in our study of equations. Now, the way that we go about solving equations is through the use of what are called inverse operations. And inverse operations are simply two mathematical operations that undo one another. Now, as far as what these might be, addition and subtraction are inverse operations. One builds values, one takes them down. Another, multiplication and division. There are others, of course, but through our study of Algebra 1, we're going to come into contact with more of them. We're going to begin with this. Now, a note here, when we have an expression that we are simplifying, we follow our general order of operations, and that is groups come first, followed by exponents, then we multiply and divide from left to right, and then we add and subtract from left to right. So we have this little memory aid called GEMDOS. Some of you might have heard it before as PEMDAS, using parentheses, but there are a lot of ways of grouping numbers and values together that do not involve parentheses, but can be categorized as groups. When we are solving an equation, we are looking for an unknown value. So we are using inverse operations. We also follow this order in inverse order. We start with subtraction and addition. If we see these present, we get rid of them first, using the opposite item. Next, we have division and multiplication. If our variable is being multiplied, we divide that value away. if our variable is being divided, we multiply to get rid of it, that other value. Next, if we have any exponents or exponent type items, we are going to get rid of those. And last, if we have grouping symbols, we then tear apart the group according to what it means. So if we have stuff happening on the top of a fraction bar, including our variable, we get rid of everything else and then we tear apart that group. If we have other items, such as absolute value, we'll have to talk about what those mean, and those will come in later solvings and later equation lessons. But this is our basics. So with this vocabulary and background, we can now take a look at certain properties of math that have great use when we're looking at solving equations. And the properties that we're talking about here are properties of equality. There are 4 of them that we're going to be focusing on. The properties of addition, subtraction, multiplication, and division. Now when we look at these, we can look at them from a vocabulary and word English point of view, or we can look at them from a mathematical point of view. The addition property of equality tells us that adding the same value to both sides of an equation creates an equivalent equation. Now, algebraically what this means is that if I have A equal to B, then I can add the same thing, so A plus C equals B plus C. Since I added the same item, it maintains that equivalency. So numerically, if 2 equals 1 plus 1, now I can add the same thing. 2 plus 3 equals 1 plus 1 plus 3. Because this 2 was equal to the 1 plus 1, adding 3 to both sides makes both equal to 5. And we can maintain that equation and the value of that equal sign through the process. Next, subtraction property of equality. And subtraction property of equality states subtracting the same value from both sides of an equation creates an equivalent equation. Again, using the same reasoning that we had before, if A is equal to B, then A minus C is equal to B minus C. And we could take this into subtraction on the same numerical example we had before. Next up, we're going to be looking at multiplication. And, you probably guessed it, multiplying both sides of an equation by the same non-zero value creates an equivalent equation. Now here we did add in that extra feature that the value we are multiplying has to be non-zero, but the properties still hold that we had before. If A equals B, then A times C equals B times C. If we were to look at this from a numerical point of view, if 6 equals 6, then 2 times 6 equals 2 times 6. We could also break this down. Instead of using 6, we could say 4 plus 2, in which case, in parentheses, we would have to have 4 plus 2. And it would retain that same equivalence that we had before. Last comes division, which tells us dividing both sides of an equation by the same non-zero value creates an equivalent equation. So if we were to look at it, A equals B, then A divided by C equals B divided by C. And that is, of course, assuming that C cannot equal 0, and that would also hold true for the previous one. That's especially important when it comes to division because we cannot mathematically divide by 0. That's a basic idea but has some pretty interesting thought patterns behind it. So what can we do with all these properties and all these definitions that we've been working with? Well, we can use them to go through and actually solve some basic equations. So our first one here, m plus 2 6/10 equals 1 5/10. Now, as a little reminder, how do we go about solving these? We're going to think of SADMEG and run through it step by step. In this problem, do we see any subtraction or addition? And the answer is yes, we have addition happening here. So, what is our inverse operation for addition? It is subtraction. I'm going to go through and subtract 2 6/10 from both sides of my equal sign. Now on the left, that's going to have me just equaling m. On the right, 1 5/10 minus 2 6/10. When our signs are different, going a little review of our positive and negative numbers, we take the larger number, in this case 2 6/10 is larger, 2 6/10, and we're going to subtract the smaller. 1 5/10 is indeed smaller. If we subtract these, 6 minus 5 is 1, 2 minus 1 is also 1, so we end up with 1 1/10, and then we keep the sign of the bigger number. Well, 2 6/10 was bigger, and it was originally subtraction, so we come up with a negative 1 1/10. And if you need a review of positive and negative numbers, be sure to speak to your teacher about that, so you can have a little bit of more personal conversations on that topic. Next equation we're going to solve. Let's take a look at 2/3 equaling p minus 1/6. Well, again, we're going to go through our checklist. Do we see any subtraction or addition happening here? The answer is yes, we have subtraction. So in order to retain equivalency, we're going to add that value that was being subtracted. In this case, I'm adding 1/6. That gives me p equaling, we have 2/3 plus 1/6. Quick refresher again on my subtraction, or my addition of fractions. 2/3 plus 1/6. In order to add fractions, I have to have equivalent denominators. My equivalent denominator here is in fact 6, which means I have to change this 2/3 into 4/6 by multiplying top and bottom by 2. So 4/6 plus 1/6 is 5/6. Our next equation is going to give us 17 equaling 23 plus q. Now, how are we going to solve this? Well, do we see any subtraction or addition, our first step? Yes, we have addition, but the question is what is being added onto our value q. In this case, we are adding a positive 23. Now, in order to get rid of a positive 23, we're going to subtract. It's not that the value 23 is being added to q, it's that a positive 23 is being added to q. So, we're going to go through now and subtract, inverse operation, that value. And again, we have one positive, one negative, so we're going to go big number minus small one, 23 minus 17, borrowing. We have 6. 23 was bigger, it was negative, so we come out with a negative 6 as our value for q. Now, continuing, what are some other equations we could do? Well, we can take y divided by 3 equaling negative 6. Running through our SADMEG, do we see any subtraction or addition? The answer is no. So, next step, do we see any division or multiplication? Well, yes, we have division by 3. So, in order to undo this, we are going to multiply both sides of this equation by 3. Y will equal a negative 18. 6 times 3 is 18. There was one negative sign, so our answer comes out as a negative 18. Our next equation will be 6 pi equals 2 pi times the variable x. Well, it looks in this case on a quick glance that we have two variables, x and pi. But remember, pi is actually a number. So, what is happening to our x? Do we have a subtraction or addition? No. Do we have any division or multiplication? Our answer here is yes. What is our variable x being multiplied by? Well, it's being multiplied by the entire quantity of 2 pi. So how do I get rid of that quantity? Well, the inverse operation for multiplication is division. I will divide both sides by 2 pi. Divide by 2 pi. Pi divided by pi is 1. And 6 divided by 2 is 3. So the solution to this equation is 3. One last one real fast. If I can squeeze it in to the space here, I'm going to take r and divide it, or the opposite of r divided by 5 will equal a negative 6 1/10. Well, what's happening to our variable r? Is there any subtraction or addition? The answer is no. Do we have any division or multiplication? Yes. Now, what is r being divided by? Technically, it's being divided by 5, but we do have that negative sign out there. If we get rid of the 5, only the negative will stay behind. So what I'm going to do is I'm going to multiply both sides by a negative 5. A negative times a negative comes out positive. So on both sides, we will come out with a positive. R, in this case, equals 6 times 5 is 30. 1/10 times 5 is 5/10. So R is equal to 30 5/10. So a lot of basic concepts here for solving simple equations, vocabulary, and our properties of equality. Make sure you have these down because they are going to be used extensively throughout algebra and further mathematics. So, good review to get us started on what we're working with.